Hello, welcome to the video. In this video, we're going to be looking at section 8.4, where we're going to be graphing f of x equals a times by the quantity of x minus h quantity squared plus k. So we're going to figure out how we can describe the graph of y equals excuse me. I'm sorry, be f of x equals a times it by the quantity of x minus h squared. Um, Again, if you were to kind of expand this portion right here, you would realize it's a times it by the quantity of x minus h times it by the quantity of x minus h. And if you FOILed this out, it would still end up being a quadratic. Since it's still a quadratic, it is still a parabola. Now, because it's a parabola, it's still going to be the U-shaped, right side up U-shaped if A is positive, upside down U-shaped when A is negative. But when it's in this format, H and K are going to be the locations of our vertex. So one of the concepts that they want us to address in this section first is do we have what is called an even or an odd function? So what they say here is if we end up having an even function for an example, what you are going to do is you are going to substitute x with negative x in the function. So you just replace that with negative x. If you replace it with negative x and it turns out to be the same thing once it gets all simplified as the original function f of x, then we can conclude that that function is an even function. If you do the exact same thing to that function and you get the opposite of the function, then it is considered an odd function. Finally, there is a situation where it's neither the same nor is it opposite. If you get that type of scenario, then that's where you can say it's neither odd or even. So here's some examples. Each one of these, we're going to look at one that is even, one that is odd, and one that is neither. So looking at this first example, they want you to determine, so we got f of x equals 2x. So what you're going to do is you're going to go something like this. So basically, you're just substituting in x with negative x. So anywhere you see x in here, you're going to replace that with negative x. And then I like to put parentheses on there to kind of enclose it to let you know that that substitution is taking place. Once you go through the uh, the setup, you can notice that 2 times negative x is just negative 2x. Now, looking at the relationship between 2x and negative 2x, they are opposite. Since they are opposite, we can say that this is an example of an odd function. All right, so now if we look at example B, again, it's g of x equals x squared minus 2. So we're going to take that g of negative x now. And so now I'm going to say, okay, this is negative x squared minus 2. So whatever value you place in for x, whether it's 1, 2, -1, -2, it doesn't matter. The result, once you square it, will be positive. So we can now say that this is going to be x squared minus 2. Because, like, just for example, let's just say x equals 5. So if I put 5 in here, so that's negative 5 squared is positive 25. If I put 5 in here, 5 squared is still 25. And subtract by 2, you get the same answer. So that's why I can conclude that it is going to be x squared minus 2. This relationship here is the exact same. Since they are the same, we have an even function. Finally, in this page, looking at C, now we're going to look at h of negative x, which is going to be 2 times negative x here, we'll square it, plus negative x minus 2. All right, same rule as applies to example B. This negative x is being squared. Doesn't matter what the value of x is going to be, it's going to be positive. So this is just going to be 2x squared. This right here will now be minus x minus 2. So now this is a situation where it's not the same, but it's also not the opposite. So because it's neither the opposite nor the same, this is neither odd or even function. All right, so I would like you to give these a try. Um, if you're not sure, if you're having struggles, please comment down below. More than happy to uh, give you some insight on those example problems. So as you dive into the core concept of being able to identify the graphs of this new written out function, we're looking first just at f of x equals a times by the quantity of x minus h squared. So the h inside the parenthesis is the shift right or left of the vertex. So in an example, let's say I had f of x is equal to, well, let's just say 5 times it by, let's go x plus 3 quantity squared. What you have to keep in mind, because it's a minus h, it's always going to be the opposite of how it is interpreted. So because it shows up as plus 3, you're actually h is minus 3 because, you know, minus and, a negative number across the line, change of sign becomes positive. So because h is negative 3, that means that your vertex moved to the left 3 units. Okay, so that's what that means. So now, but if it was f of x equals 5 times it by x minus 3 quantity squared, now h is positive 3 because now um, it's written as the minus, so now it's going to the right 3 units, the vertex. Okay, so here they're asking you to graph the function. They want you to compare the graph to the apparent function f of x equals x squared. So we talked about with comparison, we asked for two things. The first one, back in the beginning of chapter 8, is it a vertical stretch, shrink, or neither? Since A is 1/2, absolute value 1/2, falls in between 0 and 1, this is an example of a vertical shrink. The second question that they want is what is happening to the vertex. So with the vertex, since h equals 4, the vertex is moves 4 units to the right. You could easily, I would accept it's going to be in location 0, comma, I'm sorry, 4 comma 0. And if you were to graph this, so like 1, 2, 3, 4, plot it here. A is positive, so my graph would look something like this. So here, again, I won't go in great detail about graphing the function. It's just being able to plot the points and determine, you know, is A makes it a right side up U shape upside down. But let's just compare it. So as we compare this, number 4, the first thing, it is a stretch because A is 2, 2 is greater than 1. The second thing we can say is that my vertex is going to be moving 5 units to the left because in this case h is -5, it'll be moved to the left. So go here, -5 comma 0 somewhere over here is positive, so it's right side up U-shaped. Looking at 5, when I compare, first off, A is -1, so the absolute value of -1 is 1, so it's neither a stretch nor shrink. You know, it is reflecting over the x-axis, but I'm just looking for those three. It's either stretch, shrink, or neither. Looking at the second thing with respect to the location of the vertex, I'm going to say that the vertex is going to be located at 2 comma 0. So when I graph this, 2 comma 0 is right here. A is negative, so it's going to be upside down. Now, if you have a shift in both x and y coordinates of the vertex, you're going to attach a value of k. So k talks about your vertical translation, whether you are moving it um, vertically upward positively or vertically downward in a negative sense. So essentially, when you have this version here, tell me what h is going to be equal to, and then tell me what k is going to be equal to, and then the vertex is going to be located at h comma k. And then everything else falls into place. If A is positive, writes it up U-shaped. If A is negative, upside down. Stretch or shrink is still the same comparison. So here, you know, when I compare this, you know, -2 absolute value, -2 is 2, 2 is greater than 1. This is still a vertical stretch. Now, the location of the vertex in this, now you could write out like, oh, since h is -2 and k is +3, you could write out you're moving your vertex to the left 2 units and it's going upward 3 units, or you can say vertex is going to be at location -2 comma 3. All right, you know, however you see to write it out, and then to graph this. So I got -1, -2, 1, 2, 3. Vertex is going to be located somewhere in this section, and A is negative, so we're going to have something that looks sort of something like this. Okay. Again, uh, give this one a try in yourself by yourselves. If you're not sure, again, please leave a comment down below. More than happy to help you out in these situations. Finally, in this particular one, it says The vertex is at 3 comma 6. They want you to write and graph a quadratic function that models uh, the path. So this is the only thing they tell us. All they tell us is the vertex. So using the general formula f of x equals a times by x minus h quantity squared plus k, they gave us no other parameters for this value of a. They don't know if it's, they didn't tell you if a is positive. They didn't tell you if a is negative. So my advice is don't try to overcomplicate this. Let's just make a equal 1. So with that being said, I'm just going to create one. It's f of x equals x minus, well, h is 3, so it's going to be x minus 3 quantity squared plus, this is k plus 6. Now you could have wrote a as 2, you could have wrote a as, 1/5 or -7. Still would have fit the same thing, but as long as you had x minus 3 quantity squared plus 6, you would have had the vertex located at coordinate 3 comma 6. And that is being able to graph f of x equals a times by x minus h quantity squared plus k. Hope this helps. Until next time.